Hello friends, today's question. Block A of mass m is placed over a plank B of mass 2m. Plank B is placed over smooth horizontal surface. The coefficient of friction between A and B is zero point 0.4. Block A is given velocity v0 towards right. Find the acceleration of block B relative to block A. So this is the figure A and B. A is placed over B and v0 velocity is given to A. And the friction between A and B. So let's draw first of all how the frictional force will be acting on it, both of them rather. So this is our block A and this is our block B, and there is a v0 velocity on block A. So because of this v0 velocity, block A will try to move block B towards right, the frictional force Fr, and there will be equal and opposite force Fr which will be acting on block A. Okay, so these are the frictional forces. Next, let's draw the free body diagram for each of them and then solve it further. So we can say that for block A, this is our block A, there is a v0 velocity and frictional force Fr is acting towards left. Okay. And let we say that the acceleration of block A is given as AA towards right. So from the block diagram we can see that the frictional force will be acting opposite to the velocity. So basically this acceleration will be retardation. You can see because as the frictional force R is acting opposite to the velocity, v0, therefore AA will be retardation. And there will be MEG in the downward direction, and let us suppose there is normal NA in the upward direction. So we can say that Fr, we can write the equation as equation of the motion. Therefore, equation of motion for block A will be given as Fr will be equal to Ma, mass of A, and multiply the extraction of A, as it is a retardation, so there will be negative sign for it. And we can also find out what will be the frictional force. Frictional force Fr will be equal to mu multiplied by Na, and Na will be equal to Mag, so this will be mu Mag. Substituting the value, we can write that mu Mag will be equal to minus Ma and acceleration of A. Mass cancels out, so we get acceleration of A mu is given as 0.5, so we can write this as 0.5 multiplied by g, or from here we can say acceleration of A is equal to g by 2. Now let us find out the acceleration of blank B. So we can say that for blank B, we have Fr, and let us suppose its acceleration given as AB. So from here we can say that Fr will be equal to MAB, and we already know Fr is mu MAG, so we can say that mu MAG will be equal to MB multiplied by AB, and MA is M and MB is 2M. So from here we can say acceleration of B will be equal to mu mg divided by 2M. M cancels out with M, and here mu is 0.5. So from here we can say acceleration of B is equal to g by 4. Now we are supposed to find out the relative velocity of B relative to A. So we can say that relative velocity of B with respect to A is equal to AB minus AA, and AB is g by 4, minus of minus we have g by 2. Yes, sorry, here I missed minus. G by 2. So we get this as velocity as g by 4 plus g by 2, and from here we can say that this relative will be coming as 3g by 4. So this is the relative velocity of B with respect to A. So this completes the question. Thank you.